Hi guys, in this lesson we will create a Matlab Simulink model to test our algorithm that we described in the previous lesson, and then we will follow some specific procedure to establish how we can obtain the correct model of the estimator dynamic, especially in the linear system or linear dynamics. Okay. And so, in order to open the Simulink application, I can write Simulink and push the enter button in here. And so I choose the blank model at this moment. And so I can change some specific feature in the Simulink model, the model configuration parameters in here. And so I need to select the fixed step. You may choose the variable step, but the fixed step is okay in our algorithms. And so 1e-4 should be given at this time because it's a sampling rate of our system. And so if you can choose if you choose the smallest things in here, and then our solution may be wrong. Okay. And so, firstly, we need to create some Matlab function in here, like this one. Matlab function is used to prepare some code on your Simulink application. Simulink is utilized to real-time applications, but don't make mistake, this is not a real-time application, but in the Simulink application, time is linear. And so, if you have any Matlab function, or if you have any integrator, derivative, and etc., and so you can run your system in the time order. Okay, but in the script application, we may choose or create the time response and time characteristic with the specific arrays, but the Simulink arrange the whole things itself. Okay, and so I can push the name of these things to real system in here, because in the Simulink application we don't have any real physical systems, and so we need to create some specific dynamics in here by using giving some derivative operation. Okay, and so if I open this selection in here, I give the output value x, and x should be given in here. Okay, and so as well as we need to give some input value named with the u. Okay, and so what's the output of this system? Output of this system is that x dot minus a times b plus, minus a times x plus b times u. Okay, this is our system. And so the word one, linear scalar estimation internet. You may choose the different name, but I stored my whole units or the Simulink files like this one. Okay, this is an internet example, and so I can give the name of these things. Okay, and so I can give the a like 1 and b is equal to 1. Okay, and these are simple Simulink application. And so this represents the real system dynamics. Okay, real system dynamics. Okay, and so if I have this kind of dynamics in here, and so I need to push the integrator to solve this x dot equation. Okay, and so this integrator produced the x value, and so I can push this x value to the input value on these things named with x. Okay, and so x dot in time creates the x, and so the solver or our dynamics is iterated. Okay, this is how the Simulink works. And then we need to create some input signal at this moment. Okay, and so I can give another Matlab function block in here, like this one, the controller design. In this lesson we will not follow, or we will not design the controller, but in the next lessons we will. Okay, and so I can put this as a template to implement the whole codes in a proper way. Okay, and so if I open this code, and then the output of these things U and AND should be given in here. Okay, and so in order to create the input value, we need to give the some time operation here, or this input is created with respect to the time. Okay, and so controller design is the name of this function, and then I can give the some input value. Okay, and so how can we give the some input value in here? Firstly, we may choose the bias value in here, like this one, and amplitude times sin or sinus operation omega t. Okay, and so omega 2 times p times f, and f is equal to the 0.1. Okay, this simple operation. And so if I have this kind of operation, I can push this u value or feed this u value into the real system dynamics, and so it's our input, and so this creates some simple dynamics. Okay, and so in order to create or take the simulation time, I should add the clock operator in here. Okay, and so if I have this kind of information, and then I can give the some scope value. Okay, in order to what? In order to show our response at this moment. Okay, and so I should check the u value as well in here. Okay, and so if I run this code or push the run button, and then I'm sorry, the bias not defined in here. Bias is 5, amplitude is 2. So arbitrary number, you can choose or pick any number in here, but you should give at this moment. Okay, and so if I run this code, the x dot produce the x by using the integrator value. Okay, and so the scopes shows us to what the time response of our system, but we know that our A and B is what is known, are known. Okay, but what if we don't know the value of the A and B? How can we estimate? And so in the previous lesson we have talked about the estimator models, and so we may use some dynamics in order to be solved in the Simulink application, and then we can estimate the proper values of the A and B. Okay, and so I can add the A out value in here, like this one, and B out value. Okay, and so A out is equal to the what? A, and B out is equal to the B. Okay, and so if I created the estimator in here, and then I should add one more Matlab function body. Okay, in order to what? In order to create the x hat dynamics, or x hat dot. Okay, and so x hat should be given in here, and then I should give some specific values to this function. Okay, estimator model. Okay, firstly you should remember that we have the three state in here: a hat dot, b hat dot, and x hat dot. Okay, and x hat dot is given like this one, and so I need to use this equation in the what, in the this model. Okay, and so the dot should be given at this moment, because if we have any dynamics in here, and so we have 3 times 1 vector should be included in Z with the name of the what, the x hat, a hat, and b hat. Okay, and so also I need to measure the x value in here like this one, and then what? Firstly, we need to create the output dynamics with what, z dot is equal to the what, the x hat dot, because we need to utilize this dynamics in here, a hat dot, b hat dot. Okay, these are 3 dynamics, and x hat dot is equal to the what, a m times x hat. It's a stabilization rule of our algorithms, and a m minus a hat times x measured plus b hat times u. Okay, a hat dot is equal to the minus gamma x error estimation should be given in here, and b hat dot is equal to the gamma times u times error estimation. Okay, and so these are the dynamics in here, and so stabilizers should be given at this moment like am 1000 value, and so the gamma is the learning factor 100. Okay, and then error estimation can be calculated by the what, x minus x hat. In our Lyapunov stability, we have used this kind of equation. Okay, and so at the beginning of this code, x hat should be selected x11, a hat is equal to the z21, and b hat is equal to the z31. Okay, these are total algorithm, because these equations coming from the what, these things, and these equations. Okay, and so if I run this code, I need to put another integrator coefficients in here like this one. X should be measured in here, and u should be supplied to this system. And so this integrator should be in the form of the 3 times 1 vector notation, and so I should choose 0 0 0. This is wrong, but why is wrong, I will explain it. Okay, and so if I run this code, and then there is no syntax error in here, but we need to use the demux operation in here like this one, 3. Okay, and so we have the mux operation in here like this one, a out should be equal to these things, and I should copy off all of these things. B out is equal to these things. Okay, and then if I run this code, and so our algorithms is okay, and so these values should be closest to these things, but it's not, and so we need to check the error value of our algorithms in here. Okay, because we need to utilize these things and minimize this error estimation, and so the error out should be also be given in here. Error out is equal to the error estimation. Okay, and so I should use the one more scope variable in here, and then I can show that this is equal to what? The 0 value. And also I can push this system like this one. The x hat should be equal to the what? This x hat value in here. Okay, and so the R estimator is okay, but the A and the B value is not equal to the other at this moment. So how can I fix this problem? In the next lesson we will talk about it. Okay.